Hi everyone. So today what we're going to do is we're going to work on working on integration for harder problems. That's really what it is. We're working on integration for harder problems, and let's look at some problems that we've done derivatives for and why we need these special ways to integrate. Okay. So let's go ahead and do a trig one. Trig one's always like the easiest one for me to talk about. So if I give you the function f of x is equal to sine of 2x. Okay, and then we ask ourselves to take the derivative of sine of 2x, d over dx of sine of 2x. This becomes sine 2x, right? Take the derivative of the outside, and then leave the inside alone, followed by the derivative of the inside, which is 2. Right? But, oh, sorry, I made a mistake here. I don't know why I said that. The derivative of sine is cosine. Okay, my mistake. Now, if I want to go backwards, if we take the integral of cosine of 2x times 2 here, dx, I'm going to stick the 2 in the back just because. I have an issue. First thing, we know the rule for the integral of cosine is this. The integral of cosine of x dx is equal to sine of x, right? Plus c. That's included plus c there. That's one of our straight identities. The integral of cosine is sine, derivative of sine is cosine. Back and forth. Easy peasy. But there's a problem here. You guys ever buy something and when you return it, it doesn't look like the way you bought it? I mean, not like you used it or anything. I mean, it just maybe got messed up in the shipping or not like you played with it for a couple weeks and got all dirty and you're trying to return it pretending it's new. I'm not saying that you're that type of person here, but it doesn't always look exactly the way it's supposed to. And that's our issue here. This cosine 2x does not actually fit this identity. It's like you're trying to trick me here to say sine of 2x is the same as, cosine of 2x is the same as cosine, and it's not. All right, so stop it. Like stop trying to play me here, okay? So what we have to do, we have to put the 2x in disguise, because I am trying to play you. So what we do is we say u is equal to 2x, because the rule is this: cosine of x, not the cosine of 2x. Okay, the rule is cosine of x, not the cosine of 2x. And what we do is we say, hey, this is called U substitution. It's not called Y substitution, it's not called S substitution. It could be called anything you want, but we've all stuck with U substitution. And here's what we're going to do. We're going to write this instead as integral of cosine of u. And you know what? U and x can be interchangeable. They're just variables. So we're kind of in the right place. But there are a couple issues with this. I'm going to go ahead and show you guys the issues. There's still a 2 and there's still a dx. Now, cosine u and dx is not my identity, is it? Okay, it's not. So I need to change dx to du. Now let me ask you, what is dx, right? And how do I get dx? And the way I get dx is the derivative of x. Can you guys agree with that? The dx is the derivative of x. So how do I get du? I need to take the derivative of u. And lucky for us, we have a u. So let's go ahead and take the derivative of u. The derivative of u, right, is, I take the derivative of both sides. So the derivative of u is du, and the derivative of 2x is 2 dx, because 2 is a constant. Okay. Now we are going to replace our dx here with this dx. So I'm going to solve for dx, because I need dx to be alone. So du over 2. So take a look, I just divided it over. And we're going to substitute it back in. The integral of cosine u to dx, which is now du over 2. We substituted it with our identity. Something really cool is going to happen. Take a look, everyone. Something really cool is going to happen. The 2's are going to divide out, right? See, the 2's are going to divide out, because 2 is from my U substitution, and we end up with the integral of cosine u du. And isn't this straight identity? The integral of cosine u is sine u. Now, we want to make sure we write this back in our x version, because right now we're in our u language. I want this in the x language. This is back to sine of, okay, what was u? U was 2x. We're back to where we started from. And we're at a plus c here because it is an indefinite integral. Okay. So, seems like a lot of work. It seems like a lot of work. But let me show you why we need this work. I'll make this problem a little harder. Here we go. The problem is going to be sine x squared. Okay, we're going to take the derivative of sine x squared. This is going to be cosine x squared times 2x. Rewriting it this time as 2x cosine of x squared. Okay, believe it. Now, imagine if you walked into a problem, an integral problem that looks like this now. Integral of 2x cosine x squared, dx. Do you have an identity for that? Nope. So there's actually a thing going on. Many of your problems, when they look like this, where you might know the integral of something, but you don't know the integral of the other part, can be done with the U substitution. Now, I want you guys to follow along with me. We're going to do the U sub, and then I'm going to give you a trick to identify U substitution problems. So we're going to take, hey, I don't know the integral of cosine x squared, but I do know the integral of cosine of x, or cosine of u. So I'm going to trade u for x squared. Okay, follow along with me. You'll realize something really cool here. Go ahead and take a derivative of u. Why? Because right now we're at this point. You guys don't need to write this, but we're at a point where 2x cosine of u dx, and we can't take the integral of this because they're not the same variable. So I need to get a du in here. I need to get out my dx and substitute it with a du. So let's go take the derivative. This is du equals to the derivative of x squared is 2x dx. We're going to bring that over. Dx is equal to du over 2x. Now take a look. We're going to go ahead and substitute this dx back into this dx. And you're going to notice something really cool. The integral of 2x cosine of x, oh sorry, that's cosine of u, I'm sorry. Cosine of u. And dx is now going to be written as du over 2x. But take a look here. That was our chain rule problem from before. So it automatically canceled that 2x. We don't even have to worry about the 2x anymore. And we're back to our problem, integral of cosine of u du. We know the cosine of integral, the integral of cosine u is sine u plus c. Now just one more step. Replace the u back to x. That's going to be sine of x squared plus c. And we're back to where we started from. Okay, so this is the basic idea of U substitution. We have a term that doesn't match our identity. So I'm going to use U substitution to sub it out. Okay, going forward and backwards. So here is a question that you guys will see on your homework. It's going to be, give me 1 second. Okay. Okay, it's going to look like this. The integral of 2x over x squared plus 1 cubed dx. And you're like, what the hell? But I'm going to tell you this is one of the easiest problems in the world. If you can identify this as a U substitution problem. So I'm going to choose this here to be my u problem. U is equal to x squared plus 1. Go ahead and take the derivative of x squared plus 1. Not going to take you much time, right? Derivative of x squared plus 1 is just 2x dx. Make sure you do write that dx because the derivative of x is dx here. And then we're going to rewrite this. This is going to be integral of 2x over u cubed. And then I'm going to change the dx here. Take a look. Dx is going to be du over 2x. du over 2x. And guess what divides out? The 2x. Now, re-looking at this problem, this is an integral of 1 over u cubed du. You could have skipped this step and wrote this instead, the integral of u to the negative 4th power. And then this is just a power rule problem. The power rule is n plus 1 over n plus 1. Right? So it's going to be u to the negative 3 over negative 3. Right? It'll be negative 4 plus 1.
Wait, how'd you get the last 3 steps?
Okay, so right here, starting from here.
Yeah, right there.
Okay.
Well, I know how you got that, but how'd you get the 3 after?
Okay, so the 3 after. I took this here, and the u part, just the inside, is x squared plus 1. So we substitute the inside with a u value, but it's still cubed. It's crap cubed. You can call it crap cubed. From this step, we got rid of the 2x. That's gone, leaving me just a 1 over u cubed. Rewriting it as, whoops, oh darn it. I did too many things, darn it. I don't know why I wrote that as a 4. That was supposed to be a 3. I'm sorry. That was supposed to be a 3. I don't know why I wrote that as a 3. As a 4.
Okay, I think that's where I got confused.
That's where, thanks for telling me about that. I'm not sure I wrote a 4. Okay, and then we do n plus 1 over n plus 1. We were going to do that anyways, because that's our integral. And that's going to be a, thanks for catching that. Sorry,
So
negative 2 plus 1.
Wait, wouldn't that mean negative 2?
Yeah,
Oh,
me too.
yeah.
Yep, I was just changing it. I was getting there. And then we're going to write plus c here, because this is an indefinite integral. Now, we're not done yet. We still have to replace the u back in. And the u we said was x squared plus 1, right? So this is going to be 1 over negative 2. All right, we're at negative in the front. Parentheses squared, because I bring the u back to the bottom. And that's going to be x squared plus 1 plus c. Okay.
Wait, why the negative? Why is there no negative on the bottom?
I put the negative in the middle.
Okay. Oh, I see.
Yeah, because negative 1. Sorry, negative 1. Let's do it. Negative 1 over 1 is the same as negative 1 over 1 or 1 over negative 1. It doesn't matter where you put the negative.
I know. I didn't see it. Sorry.
No worries. Okay. So the idea here is that we can take a problem that seems fairly impossible because it looks way too complicated. We do a U substitution and it actually gets rid of leftover parts. Now, how do you know when you have to do U substitution? Or how do you know if a U substitution is possible? The trick is when you pick a U, let's say this is my U, take the derivative in your head. What's the derivative of x squared? It's going to cancel out with whatever's on the outside. Okay, let's check this out. Did it work over here? Take x squared as my U. What's the derivative of x squared? 2x. Cancels it with what's on the outside. Even this part here, take 2x as my u. What's the derivative of 2x? Just 2 is going to cancel on the outside. Not necessary for constants. So the idea of u substitution, it makes the problem into, we have this crazy problem here, and look, it's really just this guy when I rewrite it as a u sub problem. Okay, let's give you guys one more example of a u substitution problem right now. Let's do the integral of, let's do 18x squared and 2x cubed plus 1 to the 4th power dx. Okay. This looks quite terrible. It looks really messy. Now, I'm going to tell you right now, I know this is a u substitution because if I choose 2x squared plus 1 as my u, okay, let's say I choose that as my u. What's the derivative of 2x squared? 2x cubed, 2x cubed. That's going to be 6x squared. And doesn't 6x squared get rid of this guy here? At least partially, with a 3 left over. So it makes it less complicated. Constants in an integral is not a big deal. It's just like constant multiple. We can just kick them out. So this is what we're going to do. We're going to go ahead and take it. Say u is equal to 2x cubed plus 1. Automatically take the derivative. Don't even wait for it. Just take the derivative. 6x squared dx. And you're going to see that this x squared is going to cancel out with this x squared. Super nice. It's going to make my life easier. We're going to rewrite this as dx is equal to du over 6x squared. Why? Because we want the dx. That's what we're going to replace here. So I'm going to replace this in multiple parts, multiple steps. You can just do this all in one step. I just want to show you where I'm headed here. This is equal to the integral of 18x squared. This became a u to the 4th power dx, right? We can't deal with u to the 4th and dx. We're still going to have to get rid of this dx here. The next step is going to be integral 18x squared, u to the 4th. Replace it with du over 6x squared. You should notice that variables will continue to cancel out. The x squared and the x squared and the 6 and the 18 will simplify out to become the integral of 3u to the 4th du. Oh, that's a terrible u. Now, how hard is the integral of u to the 4th? We did this as a review today. It's just power rule. This is going to be 3 u to the 5 over 5 plus c. Done. Almost done. We have to now replace back the u back in. So if I replace the u back in, it will be 3. U was 2x cubed plus 1 over 5 to the 5th power plus c. That's my indefinite integral.
You don't have to simplify that?
No, please don't.
Okay.
Because the stuff inside to the 5th power, that's like order of operations. You can't do anything else till you do that. And the 3 and the 5, I mean, I don't want to write 0.6. All right. So hopefully you guys are starting to get the rhythm here. I'm gonna give you guys some other ones before we go into actual definite integrals.
This is just the warm-up part?
No, this is actually the lesson. This is the lesson. But I haven't done the next part where we would actually plug in numbers.
Mr. Cope,
Yes.
would we be able to take 18x squared as the U substitution, or does it matter in particular?
If you try to use 18x squared, that's just say it. You can experiment and do whatever you want. It's not going to be right, but at least you can try it. If I said u was 18x squared, take the derivative. You're going to say it's du is equal to 36x, right? Do you see it? Can this 36x cancel out this crazy 2x cubed inside?
No.
No, right? So it's not going to help. So you can choose whatever you want. But the trick is pick a u that will cancel out the crap you don't want.
Okay.
So if I choose the 2x cubed, the derivative would be 6x squared, which gets rid of this other term I'd rather not have here.
Mm-hmm.
Now, it's a lot more obvious with trig functions, but let me give you another one. Let's see. The other homework questions are actually kind of easy. Here's one. Oh, let's just do another problem. Let's do the integral of 2x secant x squared tangent x squared dx. Okay. This one seems like a pretty long one. Okay. But do we know what the integral of secant tangent is? We do. That takes us back to secant, right? But we don't want to bring this extra baggage with us. So we say, hey, what if I make u equal to x squared? Take the derivative in your head. The derivative of x squared is 2x. Bam, it was going to get rid of that front value for us. So this would be du is equal to 2x dx. Rewriting it, dx is equal to du over 2x. See, we're always going to clean up dx. We're always going to clean up. So we're always going to divide our derivative over. So this was going to be up here. I'm sorry, up here is going to be the integral of 2x secant u tangent u. And I'm going to right now replace it dx with a du of du over 2x, which nicely cancels out with that dx on the outside.
Is it u squared or no?
u is not squared because I chose my u to be x squared, to be the whole exponent also. If you look here, u is x squared, so I replace the x squared with a u. And then the cool thing is that these divide out, so we have a clean problem. We have just this, secant u tangent u du, which is straight identity now. Now we can go back and use our identities. Prior to that, we couldn't use our identities. This is just secant u plus c. We know secant u is, we said u was going to be x squared.
What happened to tangent?
What's the integral of secant tangent? What's the derivative of secant?
Negative tangent.
No,
Where?
the derivative of secant is secant tangent. Excuse me.
Oh, my bad.
Yeah, it was that bad joke. Secant tangent. The derivative of secant is secant tangent.
That
Hey,
was
Mr. Co.
Yes, sir.
Do we not put this
For the
plus C at the
secant
end?
x squared, you don't
Yes,
put the
plus C.
plus. Yeah, that was what I
Yeah,
asked.
plus,
that.
yes. I just forgot to write it.
Okay.
You're right. So whenever it's an indefinite integral, you always have to write a plus c at the end. Okay. Actually, I'm gonna change up your homework today. I'm gonna give you guys an indefinite one. Okay. Give me 1 second. I'm going. All right. So we looked at this problem, the integral of 20x cubed times 5x to the fourth minus 4 to the fourth power dx, and we asked, hey, would this be a U substitution problem? And looking here, our U value is 5x to the fourth minus 4. Du is simply 20x cubed dx. That's a U here. And that does cancel really nicely too. It saves me a lot of work. So we would end up rewriting this as 20x cubed u to the fourth du over 20x cubed. And that nicely divides out with this guy. We end up with back to just a power rule problem. Integral of u to the fourth du. Rewriting this as u to the 5 over 5 plus c. Now the thing is, you have to go back and plug back in your u value. Cinderella became a princess to go to the ball, but she had to turn back to Cinderella afterwards. And then I need to also include this to the fifth power.
Mr. That's indefinite, right? So for
Yes.
if they gave us a definite integral in there,
Mhm.
At the end, would we like add in those numbers?
Yes, we will plug it back in to the x version. Now we have
Okay.
actually two ways of doing indefinite integrals, and that's why I feel like I thought I was able to do it all in one lesson, but I feel like I should break it into two. So we'll do indefinite integrals next time, and there's actually two different ways, and they'll both give you the same answer, and they both actually take the exact same amount of steps. It just depends which one you like better, but you have to know them both. Okay. Okay. All right, so let's do another one. Now this one's going to be a little unfair. So here's the integral of secant squared x tangent to the fifth x dx. Now this one is a tricky one and seems slightly impossible, but can you figure out what should be your u here? Anyone want to make a guess? What should be your u?
Would it be the 5
The 5?
or the tan to the 5?
Tan to the 5? So let's try it. If I say u is tan to the 5, I want you to right now take the derivative in your head. Before we even do it, take the derivative of tan to the 5, right? Would that cancel out the secant in the front, secant squared in the front? Probably not, because the derivative of tan to the 5 will be 5 tan to the 4x secant squared x, right? So that becomes more messy. So nice try. Well done, though. Thank you for trying it. Maybe try, hey, what derivative of what would give you secant squared?
So 10 to the third power?
Not even tan to the third. It's
No.
actually just tangent. Because what's the derivative of tangent? You guys remember this? secant squared, right?
Ah.
And it turns out it was just tangent. And when you rewrite this, and this problem literally looks terrible. It's like, what the hell? I don't know any identities that deal with secant and tangent to the fifth. And really, this is just integral of secant squared x u to the fifth. And that's du over secant squared x. And these secants divide out, leaving me just a simple integral of u to the fifth. Sorry, that's du. And we know what, we can do that power rule, u to the 6 over 6 plus c. And that gives us tangent to the 6th power over 6 plus c. Now, I want to prove that this is true. I want to prove to you guys that I'm not just making this up. I'm not faking this. Okay, I don't want to mess with you guys too much, but let's take the derivative of this.
Wait, Mr. Co, would it be tangent
The-
6x or just 6?
Tangent to the 6th power x.
Okay.
To the 6th power x. I'm going to write 1 6 in the front so you guys make it a little easier for us. So let's take the derivative of 1 6 tangent to the 6 plus c. Right? So when we take the derivative here, I'm going to take the derivative of the exponent first, right? This is power rule. Take the derivative on the outside. The 6 goes to the front. The 6 goes to the front and becomes a 5. So tangent to the 5th power x. And then the 6 cancels out with the 6, so we don't have to write that anymore. Chain rule, and the derivative of tangent is secant squared. And guess what? That's our original problem. If you guys could get back there, that's our original problem. Okay, so that's where this secant squared was from. This is actually from chain rule. And our U substitution helps us deal with these problems that would have had chain rule in them. Quite terrible. Okay. All right, let's look at another problem. Let's look at okay, this problem looks a little tweaky. And this is a log problem. Now it's the integral of ln x to the 4th power over x dx, okay? What do you think my u should be? It's getting kind of obvious more. Like if it's an exponent, it's probably going to be the stuff inside the exponent, right? So if u is going to be ln of x, the derivative of ln of x, hopefully you guys remember this, is 1 over x dx. Multiplying it over, it's going to be x du equals to dx. Now I want you guys to notice that this x here will divide out this x on the bottom. We started with this really ugly, like what the hell? But once I do U substitution, it cleans up really nicely. And let's go ahead and do the substitution. It's going to be u to the 4th power. I'm going to write it out so you guys can see it. And dx became x du. And please take note that the x's now divide out nicely. And we're back to a stupid power rule problem. U to the 4th du becomes u to the 5 over 5 plus c, replacing that u with a natural log x to the 5th power.
On the AP Calc test, this will be like a multiple choice question.
Probably, because it really is a pretty easy idea. Like this is still considered like the basics of integration. It just looks different now. Okay, let's go ahead and do one with exponentials. All right. So again, these are just kind of using power rule ones. Okay, positive integers, making it a little easier for us. Now, here's this one looks crazy ugly. E to the 5x plus 2 to the 5th power times 5 e to the 5x dx. Okay, practicing this. What do you think is going to be our u this time? Okay, so the u here would be this. So if I say u is equal to e to the 5x plus 2, I'm going to take the whole thing. Because what's the derivative of 2? Nothing, right? It's not going to bother me. And if you do it mentally in your head, you should be getting this 5e to the 5x. At least e to the 5x. Cleaning the problem up a lot. And that's kind of like the hint. You pick your u, take the derivative in your head real quick to see if it cancels out anything that's fugly. Right? Maybe I shouldn't use that word, but... So we have integral of u to the 5. This becomes, this is du is equal to e to the 5x times 5 plus 0 dx. So we're rewriting this as dx is equal to du over e to the 5x with a 5 in the front. And you can notice that this here is going to divide out this here. Right? So if you want, you can skip that step. I'll write it for you guys so you guys can see it. E to the 5x. Replace that with e to the, du over 5e to the 5x. Nicely divides that out. And we're back to a power rule. Which gives us u to the 6 over 6 plus c. Rewriting that as, don't forget to plug in back the u. So the u is all of the e to the 5x plus 2 to the 6th power over 6 plus c. Okay, so I want to add, let's do one more problem. And now this has to do with logs. It doesn't look like it's logs, but here we go. Integral of 45 x squared over 3x cubed plus 1 dx. And I want you guys to realize that this is trash, right? You look at it, you think you can do it. You're like, oh, it's just a polynomial. And you're like, crap, I don't know what to do. And it's because of that division part. If I rewrote this as something easy, if I wrote x squared, x cubed plus x over 3x, something like this. If you had something like this, you could break it up to become x cubed over 3x plus x over 3x, and then you could simplify that out and then take the integral of this separately, okay? That's if it was a nice monomial on the bottom. But if it's a binomial, you cannot break it apart like we could on the right side, right? To stress that again. If it's a monomial and you could divide the x's, great, separate them. It's an easy problem. X squared over 3 plus 1 over 3. The integral of this, pretty easy. But because it's a binomial, we can't break that. So instead, choose your sacrifice. Now, if I choose 3x squared plus 1 to be my sacrifice, take the derivative in your head. What's the derivative of 3x cubed plus 1? The derivative of 3x cubed plus 1 is 9x squared. Does 9x squared seem to divide out the value on top? It does, right? It does. And that's the idea. We can simplify this out with U substitution. And that's going to write that all out. 45 x squared over u. All right? Our dx becomes du over 9x squared. So you guys can see, I'm just literally this is all algebraic steps now. It's all just algebra 2. I can divide x squared and x squared. I can divide 9 and 45, leaving me an extra 5 behind. Right, there's an extra 5 behind. So let's rewrite this. It's the integral of 5 over u du. Now, I'm going to make this a little easier for you. I'm going to take out the 5 because it's a constant. And what is the integral of 1 over u du? Do you guys remember what the integral of 1 over u du is? This is going to be natural log of u. Don't forget the absolute value. That is necessary here. It's a straight identity. And now we have 5 natural log, replacing our u back in to be 3x cubed plus 1 plus c.
You couldn't have left it alone?
Left it back here, you mean?
No, like you You couldn't have just left it as 5u. 5 over
Uh,
u.
5 over, no, because we haven't taken the integral yet.
Mm.
Right, that the whole goal of this is to be able to take that integral. If you want, you could have went from here to here, and that is also perfectly fine, because 5 is just a constant. I just wanted to show you guys, hey, constant numbers can be kicked out. Yeah, so you can either have taken the shortcut knowing that it's just a constant, or you could take out the 5 so your brain doesn't get confused. Okay, all right. Let's look at one more style. One more style. Actually, you know what? I think we did a lot of this already. Okay. These are pretty much mainly most of the styles that we're going to be looking at. Your worksheet will reflect many of these. I'm going to make the worksheet right now, clean it up a little bit, and I'll have it out for you guys in about 10 minutes. Okay. If you guys have any questions, you guys can stick around and let me know. Okay.